Hello Internet, welcome back to Let's Make a Fractal Shader. What we're working with today is we are taking what we did last video and we're making it a little bit better. So what we did is we had it so we were sending messages to our animators directly from our publishers. What we want to do now is we're actually going to connect the two so that our publishers actually discover which material animators they're looking for. So to do that, we are going to take our publisher and we're actually going to extend the start method, I believe. And so the idea here is that instead of initializing this and exposing this publicly, we're going to actually keep it private. And we are going to do public string with a key. And so the idea here is you will match keys between publishers and events. And so since this is private, that's fine. And then we can do, let's get all components. Get components of type material animator. And we can actually just make this an enumerable type. And by doing that, it means we don't have to change the type of this, since it's just all we need is something that we can iterate over. We don't really need anything else. We don't need to initialize it or anything crazy like that. We just need something we can iterate over. So that's what this gives us. List of material animators that fit into our thing. And so how we're going to do this is we are going to run a where against these from link, where the animator, and then we want to select the ones that have animators equal to their key. So where the animator dot key is equal to our key. Yeah. I think that should work. And we just want to return that. No, is that right? We don't need a return. We can just do that. There we go. And so all this is going to do is get us an enumerable object where our all the animators, we only want the ones where the key is equal to our key. So we're selecting only the ones that match. And I'm going to do this to a list. And so the reason we have this to list back here is because these where clauses and all other link statements are evaluated lazily. And what that means is that since things are lazy, they're going to evaluate when you call them. So if I leave this off, what's going to happen is all of this whole thing is going to be stored as sort of a composition of what you need to solve. And then when I reference this animators here, every single time I reference this, it's going to run through all of these and run this where clause against this get components. And we don't want that to happen at all. So what we want is we want this to happen once and then to be forgotten. So we want a to list, and that forces the evaluation and gets it solved. And then we actually have a list that we'll reference here. If we leave this off, we'll see significantly lower performance. So there's just a quick link thing. So now we have our to list. The issue is our animator doesn't have a key. So let's add one. That's easy enough as well. Just do a string of type key. And it can't find okay. System wasn't imported. Well, I don't need that. I can just, Java is wearing off on me again. Aha! Help! Send help, please. So what we have is a key here and a key here. And they should match up in here. And so if we did this right, which should work, we should be able to just kind of fold them together, and we're getting errors. Oops. There we go. More of the Java-ness. So where it cannot be found. And that is because we did not include link. So we're going to use system.link, I want to say. I'm kind of guessing in the dark because IntelliSense is still broken. I'm recording this back to back with the other one. So it's probably just Link or Visual Studio just being bad at whatever it's doing. But anyway, what we've got now is we've got keys. And all of them are just there. So what we can do now is say, let's do pan X. And this is going to be a little bit less useful than it would be with something else. But I mean, if you're animating a different shader or doing something else, this makes a little bit more sense. This is probably overkill for this solution, but I think this should be good, especially since we don't really have very many parameters. Either way, we are going to connect things like this. These are the wrong keys to give them because they don't really describe what they're doing. They describe more the action that's happening. So if I change it, then the name's wrong. But we're going to leave it for now. So what we can do now is start this, and it breaks. That wasn't supposed to break. So what's going on? I'm guessing our animators are empty, and that is because we've got our start here, and we've got a start here. And so this is going to override our start, which don't need to do anything for, but we want to do base.start. Do we want to do that? Is that legal? It may not be legal. I think that's legal. One sec, it's been a while. Didn't get any exceptions, so I'm gonna say that's good. So I'm gonna clear these and then start. So what base, yeah, okay, it's working. What base is going to do is it's going to take the base object, which is going to be this publisher. Can't get there because Visual Studio. All right, but it's going to take this base start object, which was without calling this. Without calling it, what's going to happen is it's just going to hit this, and then it's going to stop. It's not going to call its inherited type because we already gave it a start method. So we have to explicitly say, make sure you call this method here. So base is referring to the object you're inheriting from, and then you're calling its start method. Obviously, this doesn't work if you don't inherit from things. Though I think it does, actually. Pretty sure you actually... You know what? I'll have to try that sometime. But for now, just remember if you need to call something from your base type, use start. And that is Inheritance 101 with me, I guess. Don't listen to me for inheritance teachings, because I'll just make stuff up. All right. Oh, geez. So this is what we have. And it works, or it seems to work. Yeah, there it goes off the map. That's all right. We can bring it back by changing it to the Mandelbrot set, and it will blow up. That's interesting. I don't know why we get this seed property being undefined, but the cool thing is everything's still working, and now we have these keys, so we can kind of switch these things around. So if I want to do pan, actually that's not going to work. Can't change these in real time because they are stored statically. Can't save either because I'm running. But anyway, we can't, due to this solution compared to our previous one, we can't update this anymore. So once we've started, there's no way to regenerate our list because it's generated at the start and it's never touched after that. And it's private, so nobody else can change it either. So this is the only time this gets set. So if what you have isn't set by the time start is called, it's never going to happen. And if you add any new material animators, those are going to get missed as well. So there's a bunch of issues here that I think we can solve. So Do we want to solve those? Yeah, let's do that. So we have a material animator, and it's pulling out all of this list. Now, we need two things. If there's a new material animator added, we are going to want to find all of the publishers and attach to them. And I'm trying to think, because this is going to be hard. So the issue, unless I'm very much mistaken, which I don't think I am, is Unity does not let you use properties like this and edit those publicly. Yeah, you can see they go away. So if we want to do this, the easiest way is to attach onto this set and add some additional stuff to it. We can't do that because it's not exposed in the public. It's not exposed publicly, and I don't want to write a custom inspector just for this. That seems like overkill. We could, and it would work, but it's a lot of work, and it's not really, for what we're doing, it's not really worth it. Actually, it'd be kind of cool. So, yeah, let's do that later. I'll put that on my to-do list. It'll probably get pushed back, but whatever. So we've got our key. We need to detect when this changes. And the best way to do that is to refactor this and pull this out. And we are going to, that's not how you do that. Refactor. No, that doesn't work. Can't extract it. Cool. That's just what I wanted. Okay, we're going to return an enumerable material animator called, actually we don't even need to do that. We can just do a void update animators. And we'll just set our animators like this. And then change this so that it calls it. And so the advantage here is that now our update animators is its own separate function. And it can be called from our start, but it can also be called from somewhere else, and they don't have to rely on calling the start method, which is gross. So this kind of fixes that. Then we can have other things call this, which I'm still not sure I like. The issue is we need some way to detect when keys are changed. And the issue is that keys can be changed on both the material animator and on the publisher. And the publisher is the only one that's tracking this. And it's not even tracking everything. If a material animator gets changed that isn't part of this, we don't currently have a list of those. So, what's the best way to do this? I think the best way is going to be to create an animation controller. And keep in mind, totally just spinning things off the top of my head. So this probably isn't the best solution to this problem, but it should be a solution to this problem. So what we're going to do is we're going to create a hash map of strings to enumerable publishers. No, material animators. And this is going to be animators. Okay. We can keep this private, probably. And so I'm not going to get that. So the idea here is we are going to store our animators in a hash map. And so a hash map is a bit bigger on the memory side of things. It consumes more memory. But what it lets you do is it takes a hash of whatever your key is. In this case, it's going to be strings. And it creates an array. And then based on that key, it takes a hash map or it takes a hash of that key. And so this is derived from the hash function, which I believe every object should have. So if I do this dot, like, what is it? Object, I don't know. IntelliSense is broken, so that's not going to work. But it's like a get hash function. I believe that's get hash code. And so what that's going to do is it's going to return an integer between whatever and whatever. And so the idea of a hash map is to store that at that index. So if an object has a hash code of 3, it's going to be at index 3 in our array. Now the advantage of that is that means if you can get the hash code in a like constant time, it means you can look up the object in theoretically constant time. And so because of that, we can actually take that and find which animators to update in constant time. And then the only slow part is we have to go over every animator in that list. So what this gets us is it means that so long as our material animators don't change, our publishers can publish anywhere they want. If the publisher key changes, then it's just changing what we're calling from this hash map, which theoretically is a good thing. So what we can do is public void publish to animators. And we're going to give it a float of f, I guess. That's a terrible name. Value. Okay. And then we want to publish our change. And so we're just publishing to our animators. But we're not doing this. So this is going to get us a animator. Or it's theoretically going to get us an animator. But what we want is not this. So this animator is referencing our hash map. We actually want our animators. So let's actually rename this. Let's call this the animators map. So let's also change this to dictionary because this is C# and not Java. So it's a hash map in Java. It's a dictionary in C#. They do the same thing, unless I am very much mistaken, and I don't think I am. That is not helpful. Anyway, I'm pretty sure dictionary and hash map, same thing. I don't think there's a hash map in C#. But if you're doing this in Java, use a hash map. They're the same. Anyway, so we have this. We have an animators map, and that is going to take that, and we want to look up something. From our animators map, we want to get something. We want to publish a key from this. So we're publishing a key and a value, which makes sense. So we're going to get a key here. And that's going to return us a set of animators. Then, if our animators are not null, we want to do everything else. So if we get animators, then we want to do this thing, which is going to update the material for all of them. Then the only other thing we need to do is have our material animators add themselves to this hash map. And so what we can do is we can do a void update. No, do we want to update? Not really. Shoot, what's the best way to do this? So the issue is we need to remove something from the hash map, and we also need to add it back in. So update, I don't like this, material animator. And we want to give it a material animator with a new key. And this is gross. I'll probably think of a better way to do this. But what we're doing is we have to give it the animator we want to update. But we also want to give it a new key. And so this is going to actually allow us to insert things. No, I don't like that. I don't like that at all. We're not going to do that. We're going to do a string, old key, and a new key. So the only thing this isn't going to be able to do is it's not going to be able to detect new material animators that are added. That's the only thing we're not accounting for, and I don't think we're going to account for. So we have an old key, and so what we want to do is we want to do grab the animator, which is going to be from our animators map, and we want to get something from the old key. Then we want to remove it, and I am going to totally screw up all of these names, but I think that should be fine. Let's do animators map, and then we want to add it at our new key with the animator. So all this is going to do is it's going to get the current animator with that key. It's going to remove that key from the hash map, and then it's going to add a new one with this key. Now, the issue here is this doesn't work. And the reason this doesn't work is because these are lists. And because they're lists, they're not enumerable objects, so we need to be able to add and remove. The issue is that is a very loud siren. Okay. The issue, do you mind working here? All right. Slapping things about and getting flustered. So we've got this animators map. This isn't going to get our animator. I said it was, but I was wrong. This is going to get our list of animators. And that's very important because it doesn't work this way. So we got a list of animators from that map. The issue is we also need to get old animator. Oh wait, this isn't going to work at all. Shoot. Okay, so the issue we're going to run into is this update is going to be hard. So we're going to get an old animator list, and we're going to get a new animator list. And now what we need is we need to solve this. So I'm going to remove these. Here's our issue. We have two lists. We need to find the object we want to actually remove and remove it from this old one and insert it into this new one. So that means we actually do need a reference to our material animator. And then I believe we should just be able to call old animator list dot remove an animator and new animator list dot add of animator. Now this is still not necessarily going to work, and the reason for that is that, well, we've got some issues here. So if our old animator is not null, then we want to remove it. If it's null, then our object was never there to begin with. And that's just sort of an edge case. And so this can be used now for actually inserting things into our list. Now, the other issue is if our new animator list is null, then we want our new animator list to be equal to a new, let's do a linked list of material animators. And so we're using a linked list here because things are going to be moving about and we're just iterating over things. So the advantages here are we don't need to index into specific elements. What we do need to do is iterate over things and quickly add and delete things from it. And so a linked list is going to give us that. But with a new linked list, we need to create it if it doesn't exist, because it may not exist yet. Nobody may have been inserted into that specific key yet. And if that's happened, then that list doesn't exist, and so nothing happens. So we need to make sure that that's actually accounted for. So now that we've got that sort of sorted, we need to actually add it into our animators map. And I believe this is an insert. Could be wrong. And we want that to be the new key with the new animator list. Now, I believe this is going to throw exceptions all over the place, but that should be fine. We're going to do is void start. And all I'm going to do is get components on material animators and get a list of them. So what we want to do with this start is we want to take them all and we want to insert them into their keys. So take the animators and for each on them, and take each animator in our animators. And then we want to, well, first initialize our animators map equal to a new dictionary of type string, and then a list of material animators, like so. So that'll actually create our dictionary, but then we want to actually insert into them, which we can do with our update material animator, giving it a empty string. And then, actually, let's just use string.empty, just so it's a little bit more explicit and we don't have those weird hard-coded things. To do that, we actually do need to include the system, because that isn't included by default. And then here, we want to use our animators key as the new key. And finally, we want to insert the animator. So this seems way too elaborate, and it is, but it's fun, and it's interesting. So what this should do is it should create a new dictionary. It should find every material animator attached to the object, and then for each of those, it should insert them into our list. Now, the reason that we have this list in the first place is because since we're using a hash map, you can only have one element per key in a hash map. Otherwise, it doesn't really work. So, in order to get that working, we actually needed to add this list. And then to do that, we needed to actually modify our inserts a little bit so that we can remove things from the lists and insert them into the list if the list doesn't exist. So that's that. One of the interesting things is you'll notice our add is actually after we insert it into our list. And the reason that's happening is because our new animator list is actually going to be a reference to this linked list. So even though we inserted this into our dictionary, we still have the same reference to that object here as we did here. So it's not like we're inserting value types like you do with some objects, say ints, for example. If you do this with an int and then change it afterwards, you're working with two entirely different values, so that doesn't change. But here, since we're using linked lists, you can actually have that reference and use the object stuff. So if you change it, it will change the reference everywhere it's used, which includes this hash map. So we can update it like that. Then we have publish to animators, which is going to actually invoke things on those. And theoretically that should work. The only thing we need to do to get that working is stick a require component on here of a type of our animation controller. And now that we have that, we can do a private reference to one of them. So we have our controller. We want to take the reference to our controller and get the component for it. What is it? Animation controller. So if we take that, we can get rid of this update animators thing. That's not needed anymore. And this publish change gets super simple. All we're doing is doing controller dot something publish to animators. And all this does is takes a key and a value. So now we are publishing all the way back. So our publisher is running back to our animation controller, and then that is actually going and updating our material animators, which are here. And you'll notice these haven't changed. The only difference is this new public string key. That's the only change that was needed here. Everything else was done here and here. So, assuming that was all right, it probably wasn't. We should get we'll get a ton of compile errors, and then everything will be angry at me. So, what's it angry at this time? No get. Shoot. What is... So I know you can index into things like this, but I believe that doing it this operator overloaded way. So this is a fun C# thing. C# has operator overloads, if you didn't know. And so that allows certain objects to override how operators in the language actually work. So you can actually add to a dictionary. So if I do an animators map, I believe you can do a plus equals the whatever. You can just add it that way instead of writing it out explicitly. I don't recommend you do that, but you can do that. And this is another example of that. So you can do these brackets, which is sort of the array indexing thing. But we can do this with any key because it's a dictionary. So that's how that works. I think this has issues though. If I remember, I believe it'll throw an exception if it doesn't find it. I believe what we had would have thrown an exception anyway. I was just going to see what happened, but apparently we can't do that. So we're going to do things right, or not at all. So that got rid of all of those errors. Let's drag this over so we can see a little bit more. Can't convert a linked list to an iList. What? I'm sorry, that doesn't make a bit of sense. Okay, let's skip that one. Does not contain a definition for insert. How about add? Sorry, I have to guess in the dark because I do not have IntelliSense for whatever reason. And I can't actually... Oh, I can navigate to the type. Oh, it doesn't implement a list. That's really interesting. It does implement a collection though, so we can use that instead. So we just need to change these list references to collection references. And I believe a collection reference is just an older version. So it's just going to allow us to add and remove from that. So it's just a more explicit enumerable thing that you can modify pretty much. So that fixes that? Maybe? We'll find out. Yes. So, theoretically, if this worked, and we saved our keys, which we apparently did not, then this should map to that, and that should map to that, and it should all work. It's not going to, is it? Nope, not even close. Okay. So everything is null pointering, and that is because... What? Our component doesn't work. Object reference not set to an instance of an object. Oh. So one thing to note, when you add a require component to an object, if the script is already attached to that object, it does not retroactively go and add the required component. Learned that a few times, but that's what happened here. So this animation controller is required by some of these publishers, but even though they require it, they didn't add it because they were already on this object. And that would just, there would be weird side effects that would happen there. So now we're getting some better issues. I wouldn't say better, I guess, but okay. Can't get to that. So what's happening is things are not present in our map, which we knew was going to happen. That was kind of a known thing. But it should be a thing we can fix. And so we've got this. Yeah, so we want to take our old animators list inside of this and do on our animators map dot has key. I believe that's the correct. I think that's the right thing. We can actually look. What is it? We've got a list of keys, bunch of other stuff. Contains key is what we want. And so what we're doing here is we're changing this so if a key exists with this object, we want to take it and then remove it from that. Otherwise, it's not going to do anything. And we're going to need something similar for this. I'm just going to move that in there. And we want to bring this into, not here actually. We want a new animator list. That's not what I want either. I want a list of material animators. There we go. Animator list. Why not? That works for me. And so that's going to be just sitting there. And so either we're going to create a new one. Sorry, that's wrong. Either we're going to create a new one, or we are going to get the current one like that, if our new key exists. So how this is going to work is similar to that last one. If the animators map contains a key of new key, like so, then, or it doesn't contain one, let's make that not. So if it doesn't have a key of the new one, we want to create it and then assign it to this new animators list like so. Otherwise, just grab it and stick it here. Then finally add it to that list. And that should get rid of our null pointers. Or not, maybe it'll blow up in our face. That's a good alternative. That's not going to work, is it? Didn't like that a bit. Can't use iList. iCollection. There we go. That should fix at least part of it. There. And now we can start. Those other errors will clean up. And it works. So, the cool thing... Oh, C doesn't exist. Can't find that. That's alright. What we can do now is we can do pan Y. And plug that in here, and then we can change this to pan X. And now it's doing the same thing. We got a bunch of errors, but that's all right. It's not really all right. Actually, we can fix that too. So let's do that. In this animation controller, the issue here is this, which we can fix by That's not how we want to do it. Help. Okay, there we go. So now we want to test if our animators map contains that key. Map.contains key of our key. If it does, then do this, otherwise just ignore it. And so that should be, theoretically, it should be a constant time lookup of our animation. And we can change it. And we don't get any other errors except this. Which I don't really know what's going on there. That's been going on for a while. We'll just pretend like that doesn't exist. Don't tell anybody, except the internet. All right, so what we've got now is we have a animation, and it works. And we can kind of plug whatever we want into this, and it just does its thing. That was cool. So the advantage here, everything is sort of dynamic. And if we need to update our material animators, there's a script here, the update material animator, that will do that for us. And so this way we can actually dynamically attach to any animator. It doesn't have to be on a material like I'm using here. You can attach it to anything you want, and it should work. So hopefully this was interesting, and if you liked it, let me know in the comments below. I'm really curious what you guys think, and I'm always looking for new ideas, so let me know. But that's it for now, so hope to see you guys in the next video. See you, Internet!